Every chip in your phone, your laptop, your car, made with a gas most people have never heard of. And for years, more than half the world's supply came from 2 industrial plants in Ukraine. Then Russia invaded, and both plants went dark overnight. What happened next tells you exactly how fragile the technology stack really is. Neon is not exotic in the way that lithium or cobalt sounds exotic. It is the 8th most abundant element in the universe. But here on Earth, extracting it in the ultra-pure form that chipmakers need is extraordinarily difficult. You get neon as a byproduct of steel production, specifically carried from the air separation units that strip nitrogen and oxygen out of the atmosphere to feed blast furnaces. The steel plants of Soviet Ukraine ran those separation units for decades, and the byproduct neon was captured, purified, and sold. By the time the Soviet Union collapsed, Ukrainian companies had built up deep expertise in taking that raw neon and refining it to semiconductor-grade, 99.9999% purity. No other region had the capacity, the know-how, or the reason to build it. That left the chip industry in a position it did not fully appreciate until February 24, 2022. Here is what neon actually does in a semiconductor fab. Chipmakers use excimer lasers, argon fluoride lasers running at 193 nanometers, to carve circuit patterns onto silicon wafers. That process is called deep ultraviolet lithography, and it is the step that turns raw silicon into a functioning transistor. Neon is the buffer gas in those lasers, making up roughly 95% of the gas mixture by volume. Without high-purity neon, the laser degrades. Without the laser, there is no chip. Carried every leading-edge fab on the planet, TSMC in Taiwan, Samsung in South Korea, Intel in the United States, runs on RF lithography. All of them needed Ukrainian neon. 2 companies dominated the supply: Ingas, based in Mariupol, and Creoin, based in Odesa. Together they supplied an estimated 45 to 54% of the world's semiconductor-grade neon, according to a 2022 U.S. International Trade Commission briefing. For American chipmakers specifically, the concentration was even higher. Ukraine supplied more than 90% of U.S. semiconductor-grade neon imports. Ingas alone was producing 15,000 to 20,000 cubic meters of neon per month, with roughly 75% of that output going directly to the chip industry. When Russia began shelling Mariupol in the first week of the invasion, Ingas stopped production. The plant was ultimately destroyed during the siege of the city. Carried Creoin and Odesa suspended operations days later. In a matter of days, roughly half of global semiconductor neon capacity simply vanished. The price signal was immediate and brutal. Neon spot prices had already been climbing on invasion fears, up roughly 500% from December 2021 by early March 2022, according to CNBC market data. Some reports put the peak spike even higher at over 600%. Chipmakers scrambled. Purchasing teams that had never thought about neon as a supply risk were suddenly calling every industrial gas supplier on the planet. This was not the first warning. The 2014 Crimea annexation had caused a smaller neon price spike, and some fabs had quietly begun building inventory after that episode. Those reserves, typically 3 to 6 months of supply, were the only thing standing between the March 2022 crisis and actual production shutdowns. The industry survived for a simple reason: it had buffers. Intel, Samsung, and TSMC publicly confirmed they held strategic neon reserves sufficient to keep lines running. But the buffer was finite. If the war had dragged on another 6 months without any supply response, which it very nearly did, fabs would have started rationing. What actually saved the industry was diversification at speed. Air Liquide, the French industrial gas giant, accelerated commissioning of new neon extraction capacity in China and elsewhere. Chinese steel mills ramped up their own neon byproduct capture. South Korean and Taiwanese suppliers began qualifying alternative sources. And something else happened that nobody had anticipated. The crisis forced the industry to take recycling seriously. In 2024, SK Hynix and its Korean partner TSMC announced the first industrial-scale neon recycling technology, capturing discharged neon from the laser's exhaust stream, purifying it, and feeding it back into production. SK Hynix expects the system to save roughly 40 billion won, about $30 million annually in import costs, and to cut a significant share of the fab's Scope 3 emissions. Samsung followed with its own recycling program, announcing it would source 75% of its neon requirement from recycled gas starting in 2025. These are not marginal efficiencies. They represent a structural reduction in dependence on any single geography. By late 2022 and into 2023, prices had come down substantially from their peak, though supply remained tighter and more expensive than the pre-war baseline. Ingas in Mariupol, carried now under Russian occupation, has not returned to its pre-war role in the global supply chain. The plant was destroyed. It is not coming back. Mariupol and Odesa pursued a different path. It established a joint venture with South Korean company GI Tech, named Cryo in Korea, aiming to move production capacity to an allied country. As of early 2024, that facility had not yet come online. Carried in Mariupol and Odesa operations remained well below pre-war levels. There is a broader pattern worth naming. Ukraine was not just a supplier. It was an invisible linchpin that had formed over decades through a combination of Soviet industrial legacy, specialized expertise, and the simple logic of comparative advantage. Nobody designed this choke point. It emerged. The chip industry did not choose to depend on two plants in Mariupol and Odesa. It just never had a reason to look. The lesson the chip industry drew, or should have drawn, is that single-point dependencies hide in plain sight. Neon is not a headline element. It does not appear in most critical minerals lists. No government was tracking it as a strategic resource before 2022. And yet it sat at the throat of the entire semiconductor supply chain, invisible until it was gone. The deeper issue is that this pattern repeats. Specialty gases, obscure precursor chemicals, single-source substrates. The chip industry runs on a long tail of inputs that each seem trivial until they are not. Ukraine taught the world what happens when a war touches one link in that chain. The response: recycling, diversification, strategic reserves, has made the system somewhat more resilient, but somewhat is not the same as safe. The question is not whether another link will break. The question is which one, and whether anyone will have seen it coming. The answer, historically, is no.